This is the solution of problem 39 in chapter 23 of the 9th edition. We have a charged object which has a mass m and a charge q. It's suspended by a string from an infinite charged sheet. The angle it makes with the charged sheet is theta. We are told that the sheet is non-conducting. The mass is 1 milligram. The charge is 2 times 10 to the minus 8th coulombs. The angle is 30 degrees. We are asked to find sigma, the charge density on the sheet. So before we do any math at all, we can look at the problem from the point of view of the charge. We have the string, which is going along this angle. The string makes an angle of theta with the vertical, so the gravitational force is vertical. The electrostatic force is out from the sheet, so it's horizontal, and the string is along this line. So if the angle between the gravitational force and the tension is theta, then the angle between the electrostatic force and the tension has to be 90 minus theta. So there are three forces. The electrostatic force, which, as I said, is perpendicular to the sheet. The gravitational force, which is vertical, or parallel to the sheet. And the tension, which is along the string. So, in static equilibrium, these three forces have to cancel. The difficulty is that we don't know what the tension is, and the other two forces are perpendicular to each other, so we can't simply set them to equal each other. What we have to do is change the frame of reference. Instead of using the lab frame of horizontal and vertical, if we change to a frame of reference oriented about the string so that we look at forces parallel and perpendicular to the string, then the tension will only have a force along the string, and so the gravitational force and the electrostatic forces will both have components perpendicular to the string, and those two components must cancel out. So here we go. Here's the diagram we had before. The charge, the string along here, the gravitational force vertically here, the electrostatic force this way. Now that we've transformed our coordinates, now we have these lines are drawn perpendicular to the string. So if the angle between here is theta, and this is 90 minus theta, then we can show that because this is a right angle, then this angle here must be theta, and this angle here must be 90 minus theta. So the electrostatic force has a component perpendicular to the string here, and the gravitational force has a component perpendicular to the string here. Those two components cancel each other. So this angle, as we said before, is theta, and this one, as we said, is 90 minus theta. So the perpendicular component of the gravitational force is the magnitude of the force times the cos of 90 minus theta. And the cos of 90 minus an angle is simply the sine of that angle. The electrostatic force, the perpendicular component, is equal to the magnitude of the force times the cos of the angle. And so when we include what the values are for these forces, now for the non-conducting sheet, the force is the charge times the electric field. The electric field for a non-conducting sheet is sigma over 2 epsilon naught. So we can make these substitutions, set the two perpendicular components to equal each other, and this gives us an equation for the charge density, which is 2 mg epsilon naught over q times the tan of theta. So then if we plug in the values that we have from the original problem, then we wind up with a value of 5 times 10 to the minus 9 coulombs per square meter.